mathematicians, happy Wednesday. Okay, so I am super pumped about the thinking that you guys did about the aquarium yesterday, and today we're gonna share work, and I'm gonna give you a new challenge, and we're just gonna keep on keeping on, okay? Okay, so first I want to take a look at student 1. I want you to just dive in and see what you notice about their work. Okay, something that I notice is that they're attending to precision as a mathematician by labeling, this is an L for length, so 12 is the length of the aquarium, 10 is the height of the aquarium, and it looks like 2 is the width of the aquarium. So within their equation, they're labeling the length, the width, and also the height. I also like that they created a model that showed the dimensions of their aquarium. A question that I have is, what unit of measure are we using for this aquarium? Are we using inches, centimeters, feet? How are we measuring this aquarium? That would be one question I have for their work, which maybe it's over here. Okay. I also like that they used pretty friendly numbers when they were trying to calculate 240, and they also showed multiple dimensions. Okay, and based on their dimensions, their aquarium changed. Like this one right here that has a height of 5 is much shorter than the aquarium that has a height of 2. One of the most important things for us to be able to do as mathematicians is be able to visualize what we're talking about. And in this case, what we're talking about is the volume of an aquarium. So if my height, just like student 1, if the height of the aquarium, if I'm saying that it's a height of 5 feet, then that's what it can be reflected in my model. Okay, if I'm saying there's a height of 10 feet, that's going to be reflected in my model. So it's going to be much taller if the height's 10 feet. So when we go ahead and we give dimensions to a specific rectangular prism, based on what we're labeling as the length, the width, and the height, it's going to change how a rectangular prism is looking. Okay, here's another mathematician's work. Okay, so far we've noticed that the first mathematician was precise by labeling the length, width, and the height, and that they also created a model to help us create a vision of what the aquarium looks like. So, what else did this mathematician do? Go ahead and see if you can make some observations. Something that I noticed is that this mathematician right here wrote 6 times 4 equals 24, and they wrote their thinking. Could this help? Could this help me if I know 6 times 4 is 24? That's really friendly. Can I use this friendly equation when I'm thinking about the aquarium? I think that's a great start. It's important for us to ask ourselves as mathematicians, what do we already know about these numbers? And I think that's what this mathematician was doing to start off. This mathematician also made sure to label the unit and 240 feet cubed. So the length, the width, and the height would just need to be in feet. Okay, so the length is measured in feet, the width is measured in feet, and the height is measured in feet. Volume's the only measurement that we are going to want to put feet cubed. Just as a little summary, this is what we've seen so far from really amazing mathematicians in our classroom. So far, we've seen mathematicians start with what they know about numbers before they jump in and start trying out. What do I already know about these numbers? We've seen mathematicians label the length, the width, and the height as they're calculating, which is so strong. Another thing that we can do, though, is put length first, then width, then height into our equation so that other mathematicians looking at our work know length comes first, then width, and then height. So that's just another way we can communicate accurately or clearly as a mathematician. We've also seen mathematicians label volume as feet cube or cubic feet. And that's a way that we can recognize that this is a three-dimensional object or rectangular prism. The last thing or another thing that we've seen from mathematicians in our classroom are models. Models that are directly related to how the height looks, how the length looks, and how the width looks. Okay, we want to be able to create that picture in our mind of what the aquarium actually looks like. Okay, so I have a challenge for you today. We know that the aquarium can look a couple different ways just depending on what numbers we choose for the height, the width, and the length. Okay, it could be shorter, it could be taller, it could be wider. But my challenge for you is to create the best aquarium for the fish. And tell me why. Why is this the best aquarium for the fish? How do you know? Okay, so I have this Cheerios box. Okay, I went ahead and labeled with my tape measure what 1 foot is. And you'll see right there at the S, there's a little green mark. So here's my Cheerio box. This is 1 foot. From the bottom of the family size Honey Nut Cheerios to the S right there. Okay, so if this is 1 foot, get a picture in your brain. What is the aquarium going to look like if it has a height of 1 foot? Are the fish going to be able to survive in there? Okay, so what's the best aquarium for the fish? Challenge. Second challenge. What is the worst aquarium for the fish? What's the aquarium that's going to be the worst dimensions? Like the fish are hardly maybe even going to be able to move in there. Okay? Best aquarium, worst aquarium. I can't wait to see your designs. Good luck.